Thank you very much for the introduction and the opportunity to speak in front of you today about kind of this really interesting time that we live in, actually taking some of the theory that was presented sort of in the previous talk and applying that in a practical nature to equipment. So we're really looking at the evolution from standard industrial automation into intelligent autonomy for sustainable heat treatment. And through this talk, I'm going to try and knit together sort of some of the examples that are used today practically using machine learning, artificial intelligence, and edge control to sort of not only support sort of process control aspects, but also pick up things like compliance to heat treatment standards, support improving energy efficiency, and generally make the business easier to control. So what we're going to do is we're going to step through sort of really from the basics on data and data collection, and then go all the way through to some of the newer artificial intelligence solutions that are actually being provided in industry today. So if I kind of take us back to the early 2000s and where we were as far as a heat treatment community, most of us running heat treatment plants, a lot of those plants would be using paper chart recorders, clipboards, manual transcription. And if you think about some of the early systems that came online, the digital historians, from around 2005 onwards, sort of on the left image on the screen, this is the review historian from Eurotherm, which has been sort of in the heat treatment industry for about 25 years. Very good at capturing the basics in a heat treatment plant. So temperature, time, atmosphere. Very useful for process control and meeting audit regulations. But the problem at that point in time was these were very point solutions. So they created this kind of silo of data, and it wasn't easy to sort of leverage that data island, particularly if you had a heat treatment shop with multiple furnace manufacturers. They could all have their own different system, and trying to knit together all of those different softwares was proved very, very costly, particularly at that time. So if we kind of fast forward to the 2020s, a lot of the technology has now changed. We've actually recently brought out in the past 5 years sort of a data reviewer product, which is then sort of the update to our review historian. We tried to look at what are the things that have changed technology-wise and what are the needs of the community at large. And really it was the ease of collecting data on a shop floor. So one of the things, having native protocols on an Ethernet backbone that is now available in different protocols, different instrumentation, you need the historian to be able to ingest that information. So whether that's a protocol such as Modbus TCP, Ethernet IP, Profinet, sort of all of those protocols can now be easily ingested by modern day solutions. But what is added to that are sort of the newer protocols like OPC UA and MQTT. So enabling these systems to be able to work with those new protocols enables a very fast sort of integration of instrumentation and SCADA systems. But the one thing that we had sort of in the 2000s was this sort of data island aspect. We couldn't reuse that data. A lot of this data we capture within our heat treatment plant needs to be tamper resistant or tamper proof to meet the requirements of AMS 2750 or CQI 9. So the newer type of solutions do have the ability to push the data out using the newer protocols such as OPC UA. This allows us then to sort of leverage that tamper-proof data that was kind of packaged up all ready for audit requirements, but then push out, and now we can start to reuse that data for machine learning and artificial intelligence purposes. So here we have quite a sort of simple setup. Now we've leveraged the data from a historian. We can push it out through OPC UA, connect it fairly simply to cloud-based databases like InfluxDB, and then with just a simple API call across from Influx to Grafana, we can leverage some of the lower cost sort of machine learning algorithms in a Grafana visualization software. So here, this is one of their machine learning programs out of the box. We as Eurotherm and Watlow, we don't have any relationship with Grafana. We just use their technology because it's fairly simple and inexpensive to leverage. And so they have a model called Prophet that was originally developed by, back then, Facebook, but now Meta. So Prophet, Prophet. And this is the ability to sort of look forward and predict, sort of based on sort of taking data samples over a period of time. It can then do sort of an intelligent regression and sort of predict forward what's going to happen with that particular data, whether it's temperature related or any kind of other process control. So rather than actually have to put this type of solution down at the process control layer, which can get expensive, we can sort of leverage these lower cost tools that are available to all of us today. But the one thing that we have sort of within the process control, we've got the basics covered: time, temperature, and atmosphere, but sometimes we want to pull in other data. So it's kind of mentioned in the previous presentation about IoT and IoT devices. So these allow us to then sort of augment our heat treat process data with other data from the environment, whether it's sort of ambient temperatures, humidity, dew points, etc. We can pull a lot more data in. A lot of people want to actually pull in more energy data in to make sure that their operations are more sustainable. So we've been looking at this using a very simple setup with an edge box, collecting more data from the process, pushing this data up into an Azure platform. And because of the nature of Azure, we can sort of regionalize where that data is, so it meets sort of data governance requirements, whether it's in the US, Europe, or Asia. So we've been doing this for a number of customers in the US for the past 3 years, in Europe for the past 12 months, as an inexpensive manner to sort of pull additional data signals in and pair that with process data. And you can see on the screen, there's lots of different types of data signals that we can now sort of leverage. Now, the one benefit is, once we've got it into a platform like Azure, we can use sort of the modern tools that come with the Microsoft platform. And this is where we just start to explore the likes of artificial intelligence and particularly large language models. So here we've got the IoT box providing information, pulling into a dashboard. This is a Power BI dashboard. And so we can then leverage the tools from Microsoft to use their Copilot to actually then start to analyze the data. So if you can start imagining, now you have maybe a young, inexperienced operator that you want to train and give them more knowledge about how that process runs. And perhaps, say English is not their native language, so you want to give them sort of overviews in their language. This is all now possible today, almost out of the box. It just takes some ability with prompt engineering. So here we've got sort of a DIN controller, which is the Watlow F4T. It's hooked up to some thermocouple sensors. It pushes the data through this IoT box into the cloud, and then you've actually got the executive summary, which is just summarizing that process cycle. So that's just one way of using the LLM software. And you can sort of turn up and down sort of the variability of an LLM, because it can start to hallucinate on some data. So you can actually turn sort of the regulation of that sort of up and down to make it a little bit more precise. But you actually have detailed information that it's working from. So specific data from the actual process. So the opportunity that we have then is to say, okay, we can do that with dashboards, but what if we could do it, and that's in sort of near real time, sort of 1 to 2 minute delay from the actual process. But would it be interesting to actually then do that at the control layer? So this is something that we're just starting to look at, and we're using another kind of prototyping tool like Node-RED, which is seen here, to sort of evaluate that direct connection between sort of a device sort of publishing data and actually having the LLM look at that data in real time. So we've got a call that's being made out to sort of the open AI platform using ChatGPT. This one is ChatGPT 4.0, to sort of start to look at some particular aspects of heat treatment that maybe the large language model doesn't fully understand because it's not got detail about the likes of AMS 2750, the latest release, system accuracy testing. So we actually give it that context in the prompt window in the actual sort of application here. So you can imagine with a system accuracy test, we're looking at sort of field test instrument coupled with a master thermocouple. We're testing against that control thermocouple, but there's a lot sort of an expert knows in the field when they're putting these systems together that the large language model doesn't know. So we actually then sort of put all of that information in. What is the instrumentation type? What is the furnace class that's being used? What's the historic drift pattern for those thermocouples? Do we have that data? Can we capture it and put it into that model? And then as the model is continuously running, it's evaluating what is the drift performance of that system accuracy test and control thermocouple. So you can kind of imagine this is just one aspect of heat treatment, looking at SAT tests. If you think about all the different things sort of within a heat treatment plant that we need to keep sort of looking at on a daily basis, a weekly basis, monthly, bi-yearly, there's a lot of requirement, a lot of overhead that just goes around supporting the actual running of a particular furnace. So we've kind of taken a step back, and we looked at this about 10 years ago and said, what do we need as a business to sort of make sure that we can help the heat treatment community sort of meet these newer demands as far as data requirements? So the level of precision that you need within data. And so what we've got currently in development, and it's just going out to a few customers this month, and will be beta tested for the rest of this year before going into full release next year, is looking at a way where we can have the accuracy of a field test instrument, but sort of at the cost of a process control solution, and be able to package that up. So if you just look at sort of all that I described before from the furnace side, where we collect data at sort of a millisecond level as we're trying to control that process. And then we move it through to, say, a data recorder where we're logging at a second or a minute requirement. We move then into a system accuracy test, sort of maybe a handheld calibrator, and we're doing that either weekly or monthly. And then we get to temperature uniformity surveys, which are being done every month, every 3 months, or every 6 months. Everything's sort of at a different time scale. Each of these units has its own different interface, different calibration requirement, different accuracy requirement. To manage all of this, we kind of do naturally at the moment within our heat treatment plants, but it's a lot of overhead. It costs a lot. So being able to sort of take a simple solution that satisfies all of these requirements as far as accuracy is concerned, but put it in a structure where it's much easier to use and only have the amount of I/O in the place that you need it when you need it. That's what we've been sort of developing over the past few years. So we have one of the prototypes for on display sort of downstairs at our booth 12, if anyone wants to sort of come and see that later in between the breaks of the conference. But it is a patented I/O solution. So it is high accuracy, meeting that field test requirement, but it is cost efficient to sort of be used across all of the requirements in a heat treatment plant. So hopefully that gives you a sort of a bit of an insight into some of the practical solutions that are now available within a heat treatment setup. So looking at where machine learning can help, artificial intelligence, so looked at that node RED and the development of large language models. And even now we're starting to look at sort of SLMs, small language models that we can then actually install at the edge on devices rather than actually having to make a call outside the walls of a heat treatment facility. And there we're getting into this newer phraseology of machine teaching rather than machine learning. Because if you're putting information into a prompt, you're actually teaching the language at the large language model or the small language model what you want it to understand so it can help you better.